Hi everyone, Jason from Makera here with the second part of a two-part video series on how to set up the Carvera with Solidworks and Solidworks CAM. In the first video, we looked at how to import the Carvera's 3-axis profile and set up our feeds, speeds, tool crib, and milling parameters in the technology database for Solidworks CAM. Now that we've done that, it's time to open up a project in Solidworks and prepare it for manufacturing. If you'd like, you can download this sample part from the knowledge sharing page on our wiki site, or you could open up a project of your own. So once you've opened up a sample part, we can go ahead and prepare this for manufacturing using SolidWorks CAM. Now, of course, as mentioned earlier, it's important that you set up the Carvera and all your tool parameters, and as shown in the first part of our Getting Started with SolidWorks video series. And also you'll notice that this part has been designed with a Z-up coordinate system, which is not the default for SolidWorks. Typically, the Z-forward coordinate system is the default, but whenever you're working with a mill like the Carvera, we usually design with Z in the vertical axes. So if you ever want to adjust this in your design file or even set this as your default, you can always press your view options right here, then open up more like this, and then change your up axes configuration here. And if you want, you could save that as a template so you don't have to do this every time. This is also something that can be adjusted in the CAM settings, but I find it's easier to do from the design process. So with our part, let's go ahead and switch to SolidWorks CAM. And then the first thing we need to do is define our machine. So we're going to launch this window, and we're going to select the Carvera profile, which we've created in our technology database. We're then going to switch to Tool Crib and select our Carvera example tool crib or another tool crib that you configured. You can see all the bits that should have been chosen in the technology database as shown in our first video. And if you want, you can adjust or modify tools here. And then we're going to select our Carvera 3-axis profile, which again, we've added in our first video. So now that our machine is defined, we can press OK. And the next thing that we're going to do is select our coordinate system. So we want to make sure that the coordinate system matches the coordinate system of the Carvera. And this is where you can change the coordinate system if it's not set right in your design file. I like to do a stock bounding box coordinate system. So I like to click this little stock bounding box and we'll see our stock here. And I'm going to go ahead and click on the top left corner of my stock, because that's usually where our origin is located. And you'll notice that this doesn't quite match what I need it to. The Z is up, which is good, but I need X to be going in this horizontal axis to the right and Y to be going back and not going off my part to match my Carvera. So to adjust your coordinate system, you can choose an axis that you'd like to modify. So for example, I'm going to click on X right here, and then I'm going to choose a line in my design that corresponds with what I want the X axis to be, like this line back here. And now you'll see that my coordinate system has been flipped. So Z is up, Y is back, X to the right. And that matches how my Carvera operates. So we can now press the checkbox. The next menu we're going to open is our Stock Manager. This is where you can choose the stock that you're going to be working with. And of course, you can modify and adjust your stock in your technology database, like discussed in our first video. And then you can choose your different stock type. By default, a bounding box is created, which is just enough stock to machine your part. I like to change this to a predefined stock size to actually match the stock that I'll be working with. And I'm going to adjust the size of my stock here to match the 150 by 100 millimeter by 5 millimeter part or material that I'll be using for this part. I'm then going to offset my part so that I can change its position in relative to where I'd like it to be located on the stock. And this is something that can be adjusted later in the Carvera controller. If you set your offsets now in SolidWorks CAM, then you shouldn't have to reposition your part later on. Now, when we press the checkbox, we're going to see an error message. And what this is saying is that our coordinate system, which was set earlier on the bounding box front left corner, has been changed because we just changed our stock size, and is asking, do we want to update this automatically? So we're going to hit yes. And then we're just going to click on the coordinate system button again to confirm that the coordinate system is now located in the corner of our new stock box that we just created, and that it's still facing the right way, which we can see that it is. So we can hit the checkbox. All right, and then the last thing we have to do is press the setup button to set our machine configuration in the mill setup. And what this does is it tells SolidWorks CAM the orientation of our machine. And you'll see that there's this little red arrow, and this little red arrow should be facing the same way as your mill spindle. You can see that it's not, right? So the arrow is pointed up from the bottom, but I need to point down as if my mill head is coming down towards my part. So I'm just going to press this little flip entity button. And now you can see that the arrow comes down and lands on the top of our part, like the mill head will lower on the Carvera. So that's correct. That matches our mill orientation there, so we can press the green checkbox. At this point, we've set up our machine and we can start moving into manufacturing our part. And in Solidworks CAM, the first thing you have to do is extract machinable features from your part. So that uses this internal algorithm by pressing this button right here to scan your part and find all the lines and features and contours and pockets that can actually be machined. And if it misses something, you can generate a machinable feature manually, but it's usually pretty good at analyzing your design here. So you can see we have this whole list of machinable features. I have this perimeter, I have some irregular pockets, and if I hover over them, you'll see that my text is highlighted. I have some holes, I have a big hole, and I have a whole group here, like so. And you can see that we have some machinable features ready to go. And now that we have these machinable features, we can create toolpaths for our machinable features to actually manufacture it. And there's two approaches to this. The first and the most common what folks do in SolidWorks CAM is to generate an operation plan. That will generate toolpaths for you automatically. So that will automatically generate contours and drills and cuts and paths for you and create all of your different toolpath files automatically as you go. The other way to do it is manual. So actually creating manual toolpaths using the 2.5 or 3-axis or whole machining operations. And we'll look at both in this video, but I'm going to start with the automatic generation by pressing this generate operation plan. Now what that did is it scanned all my machinable features and it created a series of toolpaths, like, I don't know, 18 or 20 toolpaths here of creating contour cuts and rough cuts and finishing cuts and a center drill and then a rough mill to go ahead and manufacture our toolpaths. And in theory, this works great, but it only works as good as your default settings. So if you don't spend a lot of time setting up your technology database, setting up your feeds, your speeds, your default profiles, your default bits, then this actually won't create a successful manufacturing plan for you. Really what it will do is potentially just break your bits and crash your machine if all the parameters in your technology database aren't set up correctly. So use this with extreme care. What it does do, though, is it gives you a good starting point that is very easy to modify. For example, I see that it's giving me some center drills, which I don't need to do. I can just run right into the drill. And actually, if you look at this large hole here, it's giving me a center drill, and then another drill, and then it's giving me a rough mill. I actually just want to mill this. I don't need to actually do a center drill. So I can actually click on any of these and delete them. And you'll see that they move to the recycling bin. So if I change my mind, I can always bring them back later. Likewise, you'll see that SolidWorks has the tendency of doing a rough mill and then a contour mill, which is usually another way of saying like a rough pass and then a finishing pass as we go. And you don't necessarily need to do that. You can often do things in just a single pass. So for example, I'm going to delete this rough pass. So all I have is this finishing pass. Likewise, for my drill down here, I don't need the center drill, so I'm going to delete that. So now I just have my drilling operation. And I'm just going to go through and again clean some of these other things up. For example, I don't like that it does this contour, this outer contour cut first. I actually want this contour cut to be last. Likewise, I want my drilling operations to be first. And then looking at my text, it looks like I don't need any of these contours. It looks like for every single text, it does a contour pass and then a rough milling pass. I'm going to keep just the rough milling pass here and delete all of the contour passes. Like so. And then lastly, we have our pocket. And it looks like the pocket has a contour and a rough mill, and I'm going to delete the contour, so I just have the roughing pass for this pocket. So I've simplified our toolpath. Still, we have a lot of toolpaths here, and we're going to have to look at these all a little bit more closely as we go. But let's go ahead and generate these toolpaths so we can actually preview what they're doing, more than just hovering over them. So I'm going to right-click our mill setup here and hit Generate Toolpath. I'm then going to simulate our toolpath, and we can preview how SolidWorks thinks our part should be machined, and it looks okay. The text didn't quite come out correctly, which is fine, but that kind of sort of looks like my part. So I would say we're halfway there. The next thing I need to do is fine-tune my other toolpaths. And you'll see that it's unhappy with these text toolpaths as I deleted some contour things from it. So I need to modify these text toolpaths here. So let's go through each toolpath one by one and analyze what's happening. I'm going to right-click and edit the definition. And even though these were generated automatically, it's always good to double-check your parameters. So for example, make sure that the correct bit has been chosen. Make sure that the correct feeds and speeds have been chosen. And you'll notice that you have the option of choosing between the operation, the materials library, or the tool. The tool option will be the default feeds and speeds that you set in your tool profile when you actually adjust your tool profile, like what we looked at in our first video. This is also where you can adjust PEC drilling functions for the drill, which is an important step. And again, this is where you can modify any of your tool parameters. Now I noticed that it did an individual toolpath for each of my text, which is a little annoying. And I can also see that it selected the wrong bit, or the bit that I wouldn't have chosen for this. So for example, if I open up my text parameters, I can see that it chose my corn bit, but instead I actually want to use my tapered engraving bit. So I'm going to select that tool instead. I can then adjust my feeds and speeds, again, based on whether I want to define them on the operation with manual feeds and speeds, based on the library of the material, or based on the actual tool feeds and speeds, which is what I've set in my tool library. Here we can go ahead and adjust our roughing. Now, if you have a roughing pass, SolidWorks will automatically not finish all the way up to the part. So, for example, you can see that there's an offset of 0.25 millimeters on a roughing pass, which means that it's not going to actually machine the entirety of your part because it wants you to then do a second tool pass and then do a finishing pass, which for high precision and really high detailed machining is the right approach. But in general, for a quick prototyping like part, you can usually get away with just one pass. So we're going to go ahead and change this allowance to 0, which will take our bit all the way up to the edge of our part. You can also do things like adjust our depth. So for example, set our maximum step down, and we can change this to be either a percentage of the tool diameter or an input value. If you look at our default feeds and speeds of what we have on our wiki site, these are all based on input values. So for example, the default step down of 0.1 millimeters, I can manually input and adjust all of these things here. You can also see that we can adjust our milling between climb or conventional milling as we go, and also enable rest machining if needed, which in this case, it is not needed because we don't have a previous toolpath. So I can now press OK. Now I want to go ahead and just simulate this one text to see if that worked well. So I'm going to generate this toolpath, then simulate this toolpath, and we should be able to see if it machined the number successfully, and it looks like it did. So it looks like we fixed that number there by changing our tool, by changing the feeds and speeds, and also by adjusting the rest machining settings. So now I'm going to go ahead and do that same thing for all of my other text. All right, so I finished adjusting all of the toolpaths for my numbers and also deleted all the extra toolpaths, so that way there's just one pass per number. And you can see that they were created here successfully, which is great. And sometimes I find that modifying the pre-made toolpaths is more work than just creating one from scratch, but it's always a good place to start, especially if you're getting started with SolidWorks CAM. But now let's go ahead and finish modifying these last couple toolpaths. So I have this rough mill here for this large pocket area. So let's go ahead and edit this definition and see what SolidWorks CAM thought would be the best approach. So looking at the tool, it looks like it chose my 3.175 by 12 millimeter end mill from my tool crib, which is exactly what I would have chosen for this. Let's go to feeds and speeds. It has a feed and speed based on this operation. I'm going to change this to feed and speed based on the tool, which will adjust my spindle speed and my X, Y, and Z feed rate based on the default parameters that I placed in my tool library. Let's go to roughing. Again, because this is a rough pass, it's going to automatically add an allowance, but I'm only going to do one pass here. I'm not going to necessarily do a second one. So I'm going to change the allowance to be 0, and there is no rest machining needed because this is just going to be a single pass as we go. You can see that we are working from a pocket out strategy, which is fine. And if you want, we can also do a cleanup pass, which is also fine. And we'll be working with clon milling. Here for a depth parameter, we're going to change this to be exact, and we're going to change this to be an input value and adjust this to match what we would recommend from our default feeds and speeds from our wiki. So 0.2 mil, 0.2 mil, and 0.2 mil for our step downs here as we go. And in this case, there's no other settings that we need to change. So we can go ahead and press OK, and you'll see that we've just added a number of step downs with this tool pass. Next, we have another roughing mill. It looks like it was using a smaller bit to clear out the corners, but my 3.175 millimeter bit should fit just fine. So we can delete this tool path here. Looks like I have another roughing mill, which I don't need, so I'm going to delete that too. And then it looks like we just have 2 more tool paths, which is our center hole and our outer hole as we go here. So let's go ahead and edit this center tool path. Let's look at what tool it decided to use. It's using the 3.175 by 12 millimeter bit, which again is what I would choose. Let's go to feeds and speeds and set this to be based on our tool defaults that we've set earlier on in our first video. Then we can go to our contour options. The allowance is going to be 0 as we go here, which is good. We're also going to work with a climbing method, and we don't need any rest machining. For our depth parameters, we can go ahead and adjust our input values of 0.2 millimeters, which is the defaults that we're going to be working with based off our feed and speed library. And our final cut amount, we can leave that as 0. If we want to do a finish at the bottom, we can, but in this case we're passing all the way through, so we don't need to finish this. This would be great if you're doing a pocket. And then you have the option for tabs. So tabs will hold your part whenever you are machining something that's going to be released. For example, the center hole is going to be released. And in Solidworks CAM, you can enable tab cutting and then adjust your settings to determine how many tabs you have. And you can see that it drew 2 tabs here. I can also adjust the size of the tabs. Now, tabs are great if you're working with softer materials or if you're working on a straight edge, but I don't actually want to have to cut a tab from the inside of this part. So I'm going to use double-sided tape for this part instead. So I'm going to just press OK and then actually not enable tabs. But tabs are great for a lot of different circumstances. And then again, there's no other settings that you typically need to change unless you're fine-tuning your different lead-ins or things like that, and if you're going for a more advanced machining approach. But this should be good to go if we press OK, like so. Now, one thing that you'll notice is that we're not actually cutting all the way through. We're cutting right to the bottom of the stock. And typically when we cut all the way through, we want to cut just a little bit past the stock, right? We want to go a little bit deeper. So how would I do that? That actually comes from the machinable feature, saying that our machinable feature would come down past the stock. So let's switch to our features tree, and let's find the feature for this hole, which would be this guy right here. You can see I can select it and it highlights in blue. And then let's go ahead and edit the end conditions of this feature. What I want to do is I want to offset the end condition. So I'm going to do a blind end condition for direction 2, and I'm going to offset this by 0.5 millimeters. And you'll see that it now comes below my part. So now my feature comes down below my part, which means I can machine past it by 0.5 millimeter. So if I press the checkbox, and if we go back to our toolpaths, and you'll see that now we're machining past our part. And we're going to go ahead and do the same thing for the outer profile as well. So let's go back to our features list. I'm going to click on the perimeter feature and edit its definition. And again, adjust this by 0.5. And you'll see that now our feature comes down below our stock, and we can hit the checkbox. Let's head back over to our toolpaths, and let's edit this contour. We'll see that these step downs are quite large, so we want to definitely adjust that. So let's open this up and check what those default parameters were. So it's using the 3.175 by 12 millimeter end mill, which is great. For our feeds and speeds, we want to switch to our tool defaults. In our contour settings, we want to go ahead and adjust our step downs and put in a specific input value of 0.2 millimeters based on our default feeds and speeds for this material. And again, if we wanted to, we can use tabs, but I'll use double-sided tape to secure my stock, so I'm not going to enable tabs. But after pressing OK, you can see that we have a number of more step downs and a much more gentle approach to actually machining this part. All right, that looks pretty good. So let's go ahead and select our mill group. Let's generate our toolpaths. I'm just going to minimize the recycling bin so you just see the toolpaths that we're actually left with. So these are all the toolpaths that we actually didn't need from the auto generation plan. And again, this would have been a little bit more effective if my technology database my parameters were set a little bit more specifically based on my needs, and if I put a little bit more time into making that more efficient. But let's go ahead and simulate this. And let's see if this looks any better from what it was when we first started this process. Yeah, that looks pretty good. So that looks like what I want my part to look like, which is great. So that's much better. So that's one approach to doing preparing a part in Solidworks CAM is after you do all of your initial tool setup, which would be the same every project, and after you extract your machinable features, you can generate an operation plan and then go through and meticulously check all the settings to ensure that this operation plan was created using the actual tools that you want, the feeds and speeds that you want, and the parameters that are importantly set for your machine. And if you set all these things, and if you set your feeds and speeds, and if you do a really nice job at setting up your defaults in your technology database, then this should work quite well as a good starting point, but never forget to double check everything. But what if you want to create a manual toolpath? And what if you didn't want to use this generate operation plan, or let's say that it missed something and you want to add something? Well, I'm not going to go ahead and delete all these. I'll leave these here now that I've gone in and I've adjusted each one to be what I need it to be. But what I am going to do is add one more toolpath to chamfer the edges of my part. And if I was going to create a manual toolpath for the roughing or drilling or contours, this is exactly what it would look like. So I'm going to create a 2.5 axis mill operation. And you'll see that we have a number of options. We can do a roughing pass if we were going to do a pocket. We can do a contour pass if we were going to cut something, or do a chamfer, which is what we're going to do. You can also do facing and thread milling here. If you were going to do a drill operation, you would choose the whole machining operation button here. And then I could choose to borrow something from a previous toolpath that I've created, but we'll do it all from scratch. We're going to go ahead and select our tool, and I'm going to choose my countersink, which is actually our chamfering bit, but that's what we called our chamfering bit in our technology database from the countersink selection. And then we have to choose the features, and this is the machinable features list that we have earlier. And you can see that the only thing I really have to work with is this perimeter here, but the perimeter here goes all the way down to the bottom of our part. And of course, to chamfer, I don't actually want to do that. I just want to chamfer this top edge. So let's go ahead and create a new feature, and we're going to create a part perimeter feature. And I should be able to click on any one of these edges here and say that it's a boss, and then choose this to be the top of the part. But for our end condition, we can't just say top of the part and stop there, or else it won't actually want to chamfer below. So we do have to give this some form of a depth, so how deep we'd like to go with our chamfering bit. So for example, I could say something like 0.2, and you'll see that the line is then brought down by 0.2. So we have a nice area that we can go ahead and machine our chamfering toolpaths. After doing that, you'll see that we'll be thrown right into our operation parameters, which is the window that we opened up every time we edited one of these default toolpaths earlier. So we can go to the tool tab, but we'll see that the correct tool was already selected from making this toolpath. We then go to feeds and speeds and adjust our feeds and speeds accordingly. I'm going to switch this to be tool. So this is going to go off my technology database tool library that I set earlier. Then we can switch over to Contour, and we're going to enable a chamfering toolpath, and that's going to blank out a lot of other features that we won't need for anything other than our chamfer milling parameters. And I'm going to adjust the length to be something much smaller, like 0.1, and also adjust my clearance to be something much smaller, like 0.1, and then press OK, and we should see our toolpath be generated here, and we can go ahead and simulate our toolpath. And we can see that now we have a nice small chamfer, which is great. Now, the only other thing I might want to change about this project is I have my chamfer happen after I do my contour cut, which is important. That's good. That's something that I need to do because, of course, I don't want to do a chamfer without the edge being cut. But because I'm only holding this part using double-sided tape, I don't actually want my countersink to push this loose. So what I actually want to do is start my contour cut, then do my countersink, and do a tool change, and then change and do and finish my contour cut. So let's go ahead and adjust this. First, I'm going to drag this contour path that is my outer profile, move it down. So now you'll see that the countersink happens before my contour path. Now let's go ahead and create one more 2.5 mil axes operation. We're going to have it be a contour mill path again. Let's select our tool 4, which is our 3.175 by 12 millimeter end mill. And then let's create a new feature. And this feature is going to be a part perimeter feature. So we can select the edge of our part and say that it's a boss feature, like so. But what we're going to do is we're going to offset -3 millimeters from the bottom of the stock. And you'll see that that brings us all the way up here, like so. Let's go ahead and create this toolpath. Our tool's already set, but we want to adjust our feeds and speeds based on what we're doing. For the contour, we're going to go ahead and set an exact depth like we did earlier with an input value of 0.2 by 0.2. And we don't need tabs because we're not going to machine all the way through. But let's go ahead and press OK. And then generate this toolpath. And you'll see that we just machined down 2 millimeters because that's what we set our feature depth to be. I'm then going to drag this to be before my countersink. So now you can see that in our toolpaths, we have a partial contour that machines 2 millimeters down. We then have our contour cut here, and then we finish machining all the way through our stock. So let's go ahead and simulate this one last time. I'm going to slow this down a little bit as well. And let's go ahead and preview this part. All right, there we go. That looks pretty good. I potentially might want to make my contour a little bit bigger. That doesn't look like that large of a contour, but it looks like an okay start. So we could always adjust our toolpaths here, but this looks pretty good. So as a quick recap in Solidworks CAM, because we just covered a lot of things here, always start by defining your machine, adjusting your coordinate system, etc. Then extract your machinable features. If you want, you can then generate an automatic plan, but don't forget to go through and check and modify the paths to make sure that they're using the correct tools, the correct feeds and speeds, all the correct settings, in case you don't have all your parameters set as they should be. If you want, you could always create a manual toolpath as well, which sometimes I find to be the more direct and accurate approach to doing these things. And you can always create a new machinable feature if one wasn't created automatically when it was extracted. Once you have all your toolpaths and you've previewed them and you simulated them, it's time to go ahead and export this as a GCode file. So we can press the post-process button here. We can choose a location on our computer to save this GCode file. And then we can go ahead and run the operation path. And you can see that we've just completed our post-process. And after pressing the checkbox, that GCode file is now exported and ready to go over to the Carvera controller. With our GCode files created, it's time to actually set up our Carvera for manufacturing. The first thing that you want to do is check to make sure that your tools are located in the tool changer that corresponds with the tools that you have in your tool crib in SolidWorks CAM. Next, we can go ahead and secure the stock to the bed of our Carvera, and because we didn't use tabs, I'm going to use double-sided tape to hold down this aluminum stock. It is always a good idea to run this job using a softer test material like epoxy tooling board or polystyrene, as discussed in our selecting stock video. Once our stock has been secured, we can launch the Carvera controller app to choose our file and prepare it for manufacturing. You can upload and select the SolidWorks part that we created here, which you can see and we have previewed in our controller. And then we can launch the Run and Config window to start operating this. Now, because we're machining this with metal and we're using the air assist, we can disable auto vacuum because we won't be using the dust collection system as it's removed, and we'll be using our air nozzle instead. If you wanted to, you can offset your work origins, but because we set this in SolidWorks CAM based on our stock size, we shouldn't need to adjust that. We do want to keep scan margin enabled. This will trace the perimeter of our part before it machines, so we can ensure that it's in the correct location. And we also want to enable Auto Z Probe, which will find the thickness of our stock. If we feel as though our stock has a lot of deviations or isn't really square, we could use auto leveling to get an accurate machining through the thickness, but that's not really needed for this thin piece of aluminum or the level of precision I'm looking for this part. So I'm going to leave that disabled. Once set, and go ahead and click Run and start to manufacture this job. After completing the scan margin and probing the surface, the Carvera will start to manufacture our part based on the toolpaths that were created. This starts with the peck drilling operations before machining the numbers in a pocket path with our engraving bit, then the larger pocket using our single flute end mill, then the larger hole using our single flute end mill before creating an outer perimeter cut, but that only cuts 3 millimeters down. The chamfering bit's then selected to create a chamfer before completing the outer contour cut. Once finished, we can vacuum away any excess chips before attempting to remove our part. You can unclamp the part carefully and peel it off the bed, and remove any double-sided tape that's on our part. Be careful for any burrs or sharp edges, which may need to be removed or sanded after finishing, and always handle cut metal with care. And there you have it. SolidWorks is a very advanced CAD program that's used in industry by a wide range of users. And the Carvera works great with SolidWorks CAM if that's the CAM solution that you're looking to use. Remember that the Carvera is of course compatible with a wide range of CAM programs in addition to SolidWorks CAM, and you can visit the software page on our wiki site to learn more about all of your options. Thanks for watching. Please don't forget to subscribe and stay tuned for more how-tos and guides.